Finally, problem 4 gives us a system with 50 ohm impedances and uses low side injection. Determine the total noise figure for that system in number 4. And then determine the intermediate frequency output frequency, the IF output frequency, and power. So, all right, we'll start with A, which is to find that NF total again. This is using the same equation format that we've used previously. And you can find that equation in your book. It's equation 3.14 that guides us how to construct this equation for the NF total. And I'm going to let you work a lot of that math and not write it out here completely, but I'll skip ahead a few steps. Just perform your dB or ratio conversions. Make sure you get to your ratio form from what's given, and then plug into the formula 3.14 as we've done in the previous 2 problems. And you should end up at a stage where you have 1.10 log of 1.52 plus 3.425 plus 0.01123 plus 0.4399 plus 0.1996 e to the minus 3. All right, so 10 log of all of that added together, which is 10 log of 5.396, which equals 7.32 dB. So 7.32 dB is our total noise figure for this particular system. For part B, we wanted to determine the IF output frequency and the power. So for part B, we are to determine the output frequency. We can look at what we're given, it tells us we use low side injection. So we know the intermediate frequency is equal to RF frequency minus frequency of the oscillator. Plugging in what we're given to there is 149.2 minus 136.8, or 12.4 megahertz as our IF frequency that we have. Now for finding the power of each of these components, we again need everything in dB so we can add them all together. So the power of the IF is just going to be adding together the incoming signal, the RF signal, plus the dB gain ratio for each component. So there will be 1, 2, 3, 4, 5, 6 total blocks that we have here, because you have the incoming signal and then 5 devices. So 6 total things added together to get your intermediate frequency. So make sure you convert everything to dB first, and then add those all together to finally find the IF power, 6.80 dBm. Remember that it's in dBm because we're using that unit for our incoming signal as well. Using dB for each device does not change that. So that takes us to the end of problem number 4, and that's all of homework 5.